Hi everyone, Ms. LaJoy here. Today we're going to go over the basics of quadratics. So previously we were looking at linear relations. These are quadratic relations. So quadratics, the graphs look like a U shape. So it's a U-shaped curve and it's called a parabola. We represent quadratics in this form. Y equals ax squared plus bx plus c. And you'll recognize that from our previous unit because an example of a quadratic would be 3x squared plus 2x plus 1. That looks very similar to what we've just finished doing with polynomials. So this is a quadratic relation. It's important to know that quadratics always have an x squared term. Okay, so quadratics will always have an x squared term. And parabolas will look like this. Okay, so instead of a graph looking like a straight line, our graphs are going to start looking like curves now. Okay, so the next part of this is you need to learn about the vertex. So quadratics have a minimum or a maximum value. The vertex can kind of look like the top of a mountain. So if I have a parabola that looks like this, right? So it could be a maximum point. Because the curve is opening downward. Or I can have a minimum point if I have a curve that looks like this. If the curve is opening upward. So just to give you an example, if I have a parabola that looks like this, let's see. So I'm going to put a dot right. Give me a second to draw this. Okay, so if I have a parabola that looks like this, my vertex is at 2 and 3. So the maximum point where it reaches right up here where I have the peak, that is my vertex. My vertex is at 2 and 3, and it just follows this curve on the way up and then on the way down. So I could say, if I had a parabola like this with a vertex at 2 and 3, that my maximum value is 3. The highest point that this reaches is 3, right? Positive 3 right there, because that is my y coordinate, right? It reaches at 3 on the y-axis. Now, in the same way that we did the maximum, we could also do a minimum. So let's see, if I have, let me plot another parabola here. So if we have there, okay, and we have this parabola, okay, the vertex of this parabola reaches down to -3, -3. So the vertex is at -3, -3. Remember, this is my x and my y coordinates. So I could say here, because I have a parabola that's opening upward, this is a minimum point, right? It's kind of like if I had a top of a mountain with a maximum point, this is kind of like going down into a valley, okay? So this is like the bottom of the valley. The lowest point that this parabola reaches is at -3, right? We're looking at the y coordinate because that determines how up or down we are. And the lowest point that this reaches on our y-axis is -3, right? So we can say that this has a minimum value of -3. Okay, so now we're going to look at the x-intercepts. So the x-intercepts are known as our zeros. So that's going to be where the parabola crosses the x-axis. So there may be 0, 1, or 2 zeros. So points where it crosses the x-axis. So let's look at some examples. So the first example, if I have a parabola that looks like this, okay, so the drawing is not great on the computer, but you see what I mean. This parabola has 2 different points where it is crossing the x-axis, right? So it's crossing right here at 1 and 0, right? The coordinates of this point right here are positive 1 on my x and 0 on my y. And it's also crossing right over here at 3 and 0 on my x and my y. So we call these the zeros because the y is always going to be 0. They are my x-intercepts. They are where I cross the x-axis. I have two different points, right? I cross at 1 and 3. So my zeros are 1 and 0 and 3 and 0. So those are my x-intercepts. Now the previous thing that we did, right, was that we were looking at a minimum or maximum value. So just for the sake of doing another example of that, what is my minimum value? Remember, this is opening upward, so it goes down into a low point, and my minimum value would be at -2 here. -2, right? So that is this x-intercept. Let's do another one. Clear this. So if we have a point here, if we have a parabola that looks like this, so it came down and it touched the line, but it didn't cross, right? It just touched the x-axis. So we would say here that our zeros, or our x-intercepts, are -3 and 0. So I only have one coordinate point here because it doesn't actually cross. It just touches the line and then goes back up. All right. Now we could have another example. So if we have a parabola that looks like this, and our midpoint of it is right down here. So what are the x-intercepts for this parabola? Well, it's kind of a trick question because there are none, right? There's no zeros or x-intercepts here because it does not cross the x-axis. So there are none. Now the next thing that we want to consider are the y-intercepts. Or the y-intercept, singular, because it's only going to cross it once if it does. So this would be where the parabola crosses the y-axis. So the coordinate will always have, well, the x will be 0 of this coordinate. So at the y-intercept, the x is always 0. So remember this from linear equations, right? When you had y equals mx plus b, b was that point where it crossed the y-axis. So in the same way, when we have a parabola, our y-intercept is going to be that point where the parabola crosses the y-axis. So for example, if we have a parabola that looks like this, so let's draw the parabola as best I can on my tablet. It's not great, but you get the idea, right? That this has a y-intercept right here. It crosses the y-axis at 0 and 2, right? Because that's the x and the y. So the x will always be 0, and the y coordinate is going to be where it crosses the y-axis. So this is our y-intercept. I'll do another example on the same graph here. Let's just change the color maybe. So we could have another one. Let's say this parabola looks like this. So still not great because it's on my computer, but you get the idea. For this purple one here, where it's crossing the y-axis is at 0 and -3. So 0 and -3. So we're remove an x and a y is our y-intercept for the purple parabola. Okay? Oops. All right, the last thing I need you to know in our intro to quadratics is about the axis of symmetry. So it's important to know that quadratics are symmetrical. So it's kind of like a mirror image. And we call that center or that mirror image part the axis of symmetry. So the axis of symmetry is going to pass right through the vertex. So for example, let's say that we have a parabola that hits right here. I'll do my best to draw this for you. I'm going to get these points on here. So this comes down here. It's very hard to draw this on the computer. All right, so we're going to pretend that I did this well enough so that the very center of this parabola, kind of, not really, is at 2 on our x-axis. Okay, you see I drew a line, a dotted line through the center. It's a good idea to do that when you find the vertex, where you find that lowest or highest point of your parabola, to take your ruler and to draw a dotted line right through the center, because right through the center is our axis of symmetry. So for this parabola, the vertex is at +2 and -2, right? So +2 on my x and -2 on my y. that means I have a minimum value of -2, right? The lowest point that this reaches is -2. And my axis of symmetry is x equals 2. So we write the axis of symmetry as x equals, and then we put that point, whatever place that it has on the x-axis, right through the center. So wherever that mirror, if you think of it as a mirror image, it's like you have one half on one side and one half on the other, and the mirror is running straight through. So wherever that mirror would be, crossing the x-axis, that is our axis of symmetry. So for this parabola, the axis of symmetry is at 2. So we write x equals 2. Let's do another example. It's going to look like this. I did a little bit of a better job there. Okay, so this parabola has a vertex. So my vertex is at -3 on my x and +2 on my y. So the vertex is -3 and 2, right? This is an x and this is the y. We can, again, find that center of the parabola. Let's use a different color for it. Find the center of the parabola and draw that dotted line right through it. Remember, that's kind of my mirror. So where is the line going straight through the parabola? Well, it's at -3 on my x, right? So the axis of symmetry is, and remember we write it as x equals -3. That's my axis of symmetry. So I want to consider the direction of opening. So that's another thing that we need to know with quadratics. So the direction of opening. And the direction of the opening is tied to our x squared term. Determines whether the curve for the parabola will open up or down. So a positive, such as x squared, will open upward. And a negative, such as -x squared, will open downward. So, for example, if we have a parabola that looks like this, it opens upward. This would be something like y equals x squared. If we have a parabola that looks like this, it opens downward. We would have something like y equals -x squared. So that term, that x squared term, determines if the parabola opens upward or downward. Okay, so we're going to bring it all together now with one example. So I've already drawn a parabola here. It's not great. I tried to make the dots pretty large so you can see where I intended for them to be. So let's just go through really quickly the different parts that we could identify to answer this question. So we have to identify all these things that are listed in pink here. So the first thing is we want to find our vertex. Remember that the vertex is going to be that center point of the parabola. So if we go right here to the center of the parabola, we can see that our vertex is at 3 on our x and 1 on our y, right here where I've just put this green dot. So our vertex is at 3 and 1. Now, what is the minimum or maximum value? Well, remember that's going to be the highest or lowest point that the parabola reaches. So the highest point that we reach here is at +1. So this has a maximum value of 1. Our zeros are x-intercepts, right? That's where our parabola crosses the x-axis. So we have 1, 0 right here and 1, 0 right here. These are my zeros. So what are my zeros? Well, one of them here is at 2 on the x and 0 on the y. So 2 and 0. And the other one is at, right over here, at 4 and 0. 4 and 0. So 2 and 0 and 4 and 0 are my zeros, or my x-intercepts. Now y-intercept, where does this parabola cross the y-axis? It's not great the way I've drawn it, but we can see that it's crossing at -6. So the coordinate for where it crosses is at 0 on my x and -6 on my y. Remember that when we have our zeros, the y is equal to 0. When we have our y-intercept, the x is always going to be 0. The direction of the opening of this parabola, does it open upward or downward? Well, this opens downward, so it's a downward curve. And what is our axis of symmetry? Remember, the axis of symmetry is that line that could run straight through the middle of the parabola. So let's just draw that out with a dotted line. So right through the center of the parabola, where does that mirror go? It goes through x equals 3, and we always write our axis of symmetry as x equals. So our axis of symmetry is at 3, x equals 3.